second workshop with Transpose. My name is Vaida, and I'm education lead at MetricsDAO. And today with us, we have Pat and Kurt um, from Transpose. And Transpose is building out a suite of APIs that provides enterprise-grade access to high-level, human-readable data across the Web3 stack. Transpose believes that building on Web3 data should be fast and simple. So excited to be bringing you this workshop today with this wonderful tooling. But before we kick this off, just a quick intro to MetricsDAO. So MetricsDAO is a Web3 analytics community. We have thousands of analysts who are actively going through our educational programs, completing analytics challenges, and also attending product sessions and workshops just like these. So, really excited for this workshop. And if you have any questions, do drop them in the chat. And we'll be answering those questions over the course of this workshop. Right. So, let's kick this off. And Pat and Kurt, over to you.
Awesome. Thank you. So we're going to break this up into two parts. I'll give an overview of the screen that you're seeing here and how you can interact with our data. And then Pat will actually walk you through a real world example and kind of get a taste of our token prices data, which is one of our most powerful data sets here at Transpose. So what you can see here is a scratch query in what we call the playground. Now, so we have a bunch of data that we provide and we index at Transpose. And one of the best ways to get integrated and explore the data that we have is through our playground. So just to give you an overview about what this page is and what you're actually seeing here. Here we have what we call a scratch query, which is where you can write SQL against all of our data sets. And now let's say you want a little bit of help with writing SQL. We have what we just built out, our AI assistant. So this is a very powerful offering where you can communicate with our assistant directly and get help writing SQL queries. Now let's say you want to understand what data we provide. On this left-hand bar here, we have all of our chains that we index, along with the different, what we call layers of the data. So you can see we have our settlement layer here, where we have kind of like our low-level data sets, like our accounts, blocks, transactions for Ethereum. As we move higher up the stack, we have our asset layer and protocol layer as well. So when you create a query in the playground, you can select new, and you can start writing here as well. Oh, I see you have a question here. What engine of SQL and Transpose? Amir, we use Postgres. So here we have our overview of our playground. Now, Pat will actually walk you through how to interact with the playground and how to build a real world application.
All right. Hey, so just want to test something out here quickly. Will that show? How would I share? Okay. Yeah, so we'll be going through a little bit on working with some of the data specifically. It's always helpful to reference here on this tab our tables, as Kurt was showing, and we have it nicely divided. One addendum I'd like to add is sort of hidden beneath in all these layers, where you simply have just NFT sales, which is the same for regardless of platform, is all the complexity beneath all the data that exists that we sort of go into and shape, organize, and mold into the same endpoint schemas. So typically data in DeFi or anything EVM related is completely been very bespoke. Most implementations are different, and so trying to get, for example, data on Uniswap pools versus Curve pools is actually an incredible challenge and takes a huge lift. And so the main thing that we do is make it extremely easy to be able to gather that data regardless of protocol. So in today's example, we'll sort of go through first very simple use cases on some of our data and token prices. And then we'll show some applications using that data, and as well as with other tables that we offer, such as DEX pools. So just going through, we can type here, start to use, we have the schema Ethereum. So that's obviously the chain we're after. And you can see here the different chains that we offer here. So Ethereum, then we token prices, just a simple run through query. As you can see, we have all sorts of tokens here. We offer token prices for not only just the tokens you'll see on Uniswap, et cetera, but any DEX we offer with DEX pools, DEX liquidity, but basically any DEX that we're tracking, any trade that happens with a token gets essentially priced at the timestamp of the trade. So you could think of token prices as sort of like an abstraction on DEX swaps, but it's still its most raw form. It's just the price of the token at any time it was traded. So you can see like the timestamps here in particular has the price of the token at a very specific second. So it's not like the times have been altered at all here. Rather, we've just constructed the USD price of a token. And this goes for LP tokens as well. We track Curves, LP token prices, Uniswaps. We track Balancers, LP token prices. These are not exactly simple to get because you have to unwrap the LP tokens into the underlying tokens, et cetera, but we know that those tokens have value. So if a wallet, for example, provides liquidity to a protocol and they obtain LP tokens to represent their share of the pool, technically those tokens have a value. And so when somebody wants to, for example, get the USD value of their wallet, they're able to get that value to a very high fidelity using our data, which really just has not been possible in this industry yet before us. So showing here, we just have token prices. I'll head to fetch the wrapped ETH address from Etherscan real quick. Then so we can filter here wrapped ETH, order by stamp sending. As you can see here, we just have the latest 10 prices that we have for wrapped ETH. Now we can do the same thing. Here are a new set of tables that we've started offering, which are OHLC tables. So this provides sort of a more cleaned up version of token prices for just relative organization. It also is like a thinner table. So it's faster to join with and join across.
For those that aren't aware, OHLC stands for open, high, low, close. So those prices over a particular interval, otherwise known as candlesticks, which some of you might be more familiar with.
And just looking at that data, as you can see here, you get the volume and you have your candlestick data represented here. So this is simple enough. We offer sort of the SDK for token prices, if you want to mention the REST endpoints for that.
Yeah, so as Pat's kind of walking you through here with SQL, you can call this SQL string directly from our SQL endpoint. You can also deploy it to your own endpoint, which we'll walk through a little bit later. But we also have this data set available through our REST endpoints, as some of you may be more familiar with calling a REST endpoint directly, but it's all in the docs. So we list it out and you can interact with it there as well.
Yeah, so if you check the documentation, you can go a little bit deeper in there, but we sort of hand curated those endpoints for very common use cases in DeFi. when you're working with this data. So for example, if you have a set of tokens and you need to get their prices at an exact block number, and you have 50 tokens, you can just in one request query for all those tokens and get the prices at that block number. That's just one example, but really just stuff that's very useful when it comes to working with this data. So next, we're going to go into actually using token prices data and joining it with some of our other tables. So we're going to comment that out there. One of the things I like to do is to show off this data with specifically DEX pools, but Curve, because Curve is just if anybody's ever actually looked on chain, it's a brutal protocol to get through. I've spent a lot of time tearing my hair out trying to parse that data, and then when you figure out that a lot of the log data that they have on chain, the receipts after people swap tokens on Curve turn out to be logged incorrectly, and then you have to handle that. It's a real mess. So, but we've gone through and made sure to parse all of that data correctly so that you can obtain it just as easily as you can with, as I was saying, Uniswap. So we can do exchange name equals Curve. There we go. So here in the DEX pools table, you'll note that we have the exchange name, the contract version, the pool address, which is the contract address column here. It's creation data, and then it has an array of all the token addresses that are actually associated with the pool. So this data actually turns out to be extremely useful. We also have extra metadata that's protocol related. So as you can notice, if anybody, like I said, works with Curve data, this can be very useful, including the LP token address. And so here, what we can do to sort of obtain the individual token addresses, if we want to get those out of the array and turn them into individual rows, we can cross join unnest token addresses as pool token, and we'll keep contract address as pool address, and there we have each pool address and each pool token. And this is cool because you can start to be able to utilize this data in more context. So let's say the example that we want to go to is obtaining the TVL for each pool on that Curve offers. So here we're going to go in and then use another table that we have, which is DEX liquidity. DEX liquidity is nice as it offers pretty much a formatted view for all the liquidity events that occur in a pool. And there's essentially three that we've categorized, which are adding liquidity, removing liquidity, and swapping with a pool. So what we can do here is get the latest liquidity events for each pool here in each token, as each row in DEX liquidity corresponds to a pool token pair, and it gets the pool balance of that token. So what we can do, we can use another cross join lateral. And if anybody's familiar with our platform, this is sort of an operation that gets abused. It's a cross join lateral, but it's extremely easy to use, and it fits perfectly with the way that our data is sort of structured. And what it essentially does is for each row here, it evaluates them one by one, and then will join whatever other data you want by that row. So we can do pool balance. I'm going to give this an alias. select pool balance from Ethereum DEX liquidity DL, where the row in the pool address in the DEX liquidity table is equal to the pool address in the pools table. And we'll do the same for the token equals dp dot pool token. One thing you may notice here is that when you use unnest, you could do it right here as pool token. One thing about Postgres is when you unnest it right here, you can't use this value in this subquery, cross join lateral. But if you cross join it, then this value becomes available within the same query. So if you unnested it here, you would need to turn this into a CTE and then do any more operations after. But we don't have to do that because we can just cross join here. There's obviously performance trade-offs, et cetera, et cetera. It's just something one has to experiment with, but so it's a good thing to know. So if we fetch the pool balance for each pool address and pool token, and we want to get the latest one ordered by the DEX liquidity timestamp descending limit 1 DL. All right, so this is going to fetch the latest pool balance for each pool and token pair. Let's see, dp.pool token. There we go. All right, and then we want to add pool balance. Okay. All right. So there we just have the raw token balances, the latest raw token balances for every pool and token there exists on Curve. This is pretty cool. Now we're going and we can do a lot more with this data. So another thing we can do is then join the Ethereum.tokens table. And why this is necessary is because we want to get the decimals for each token so that we can format this pool balance by the token decimals. Once it's decimalized, then we sort of have a balance we can multiply by the USD price and actually get a USD liquidity value for. So we'll call tokens T on T.contract address equals the pool token. And then we can do 10 raised to the T.decimals as pool balance. Well, we can get cute and add the symbol of the token. Let's see, contract address is ambiguous. We'll do DP. What happens here is if you join here, it says it's ambiguous. That's because the tokens table has a contract address column. So it doesn't know which one to reference. So we want to make sure that we're getting the DEX pools contract address here. And okay, this is nice. Look, we've got seed I in this particular pool. It's pool balance, a big number. And we have this for all pools. This is really cool. We can see how much raw staked ETH is in this particular pool. And each of these links just links directly to Etherscan. So you can go in and observe specifically a little bit more through Etherscan's UI in the pool. Then finally, we can, to come full circle, we can finally bring in the token prices table. We'll do another cross join lateral. Select price from Ethereum.token prices. We'll call it TP, where TP dot token address equals pool token, and then order by timestamp descending 1 PP, and then we'll just, for good measure, oh, we have token prices. And what we can do finally, multiply it here. Yeah, and rename this column. All right. So now we have the USD value of each token in each pool. So that's very cool.
So now a few ways to build on top of this. So now Pat did an excellent job at explaining how you can interact with our data and build queries on our playground. But let's say you're ready to actually integrate this with your production application. So you have a few different approaches that you can take. One being our SQL endpoint, where you can just paste a SQL query directly and pass it into our endpoint as a parameter. However, this is a pretty big SQL query, so it won't exactly be the prettiest to pass this in as a parameter. So one thing you can do now is use what we call our deployed endpoint. So Pat, do you want to show how you can deploy an endpoint?
Sure. Yeah. So
we'll name.
Yeah. Let's see. Curve pool token. A pool token TVL USD demo. Okay, we can save that, and then we can deploy here. We are not going to do it to an existing. We'll create a new endpoint and we'll call it demo. Create the endpoint. If we want to keep it private, no one can see it. If we want to push it public, it will be able to be seen in the atlas. So that's up to you. We'll keep it public here. And then we can deploy it. Okay. Then we can go here. We see, oh, look, there it is. And then we can press run. It'll do the same thing. This is an immutable endpoint. You can't change it. You can only go in and delete it, delete the endpoint, or delete the particular query. If you want to update this query, you go back here to these. And for example, let's say instead of just individual tokens, we want to just get the TVL of each pool. So here we'll do a sum here. Delete this. TVL. We'll do pool TVL USD. We need to group by one. Group by the first column, and we sum each token's TVL USD here. We'll order by TVL USD descending. Okay. And that's TVL per pool. So we just updated this query. Let's redeploy. Let's see.
To our demo.
Yep. And we're deploying back to the same one. Atlas. No. We'll go to endpoint, the demo. We have two. We want to delete the old one. Okay. But we still have our new one. And we have the TVL. So, and then, you could sum that again, by the way, and get TVL for curve. That's essentially what DeFi Llama does. So that's pretty powerful functionality. It's faster than any other way you could get it in Web3. And so you can start, really what you learn here is just how easy it is to sort of join across different tables and start to construct abstractions and turn just the data that you typically see in DeFi into actual information. Kurt, you want to go in on another aspect?
Yeah. So since SQL is extremely flexible and you can write these very powerful queries directly in our editor, let's say you don't want to write a new query for each use case, and you want to use a query for, let's say, in this particular example, a variety of exchanges, we support parameterization, which is described as double brackets, which Pat will input right now. So.
Right. So here, we'll call it just DEX name, and then we have a parameter
that automatically shows up in our sidebar. So if we want to use the same exchange name as the previous example, we can pass in curve, and you'll see that it returns the same results. Now, for deployed endpoints and whatnot, those also support parameterization. So you can pass in curve as a parameter to your deployed endpoint, and that way you can programmatically pass in whatever variables you want.
Right. So, and another point on the endpoints here is what's nice is like when you want to just create the code snippet here, all you have to do to be able to call this is just this URL. You don't have to include clunky SQL code into your application, and you know that this isn't going to change unless deleted here, like actually on the platform. So it helps makes things organized, clean, and concise, so that you really just don't have to worry about it. But yeah, we have our parameters here, and then when you're running that through code, you simply enter in in a parameters field upon request just what the name of this exchange is, or whatever your parameter.
And helpful guides are found in our documentation. We document this quite extensively, and also happy to answer any questions in our Discord as well. So, any questions from the audience?
Okay, it looks like so far we don't have any questions, but if anyone has anything, please drop that in the chat.
Awesome. Well, thank you for having us. I hope this was extremely useful. We're always willing to answer questions. Drop by on our Discord. We're very active there. The team is extremely active, and we love helping out our community. So stop by and say hello.
Amazing. Thank you so much for this wonderful workshop. And we'll also link your Discord here in the chat to join your community. And if, for someone, if they have any more questions coming up later, yeah, you can just ask in Transpose's Discord. Right. Is there anything else you'd like to mention before we finish today?
Yeah, well, we're coming out soon with even more data. It's not just limited to what we have here now, but mainly what we cover at the moment: NFT sales, DEX liquidity. You can track bridge events, DEX pools, DEX swaps, Tornado Cash. We have contract labels. Soon we'll be coming out with even more useful data, which also includes lending protocols and eventually yield protocols. So everything that's essentially used in DeFi will be fully covered by us.
Also, if you have particular use cases, like we're always willing to work together with the community to help best suit your needs. So happy to hear if there's any additional data sets you want, or we can help build queries as well for our existing data sets.
Yeah, absolutely. So please come by, drop by the Discord, hit the website, and let us know what you think, or we'd love some feedback. So thank you.
Amazing. Thank you so much for joining us today. And thank you everyone for attending. It was great having you here. And have a lovely day or evening ahead. Bye-bye.